Good afternoon, everyone. So it's great to be here. It's the first time for me in a ClueCon. So my name is Pratik Patel. Today I'm going to share about building a global voice platform with the local intelligence. In this, we talk about the challenges, the technical solution, and how this approach will be helped to grow a business and the technology team. In that, we are covering the comparing the cloud infrastructure scalable, region-specific routing, and the compliances for providing the better voice platform. So moving forward, let's get started with the quick introduction about myself. I'm working as a tech lead in INX Technologies. I have more than 7 years of experience in the telecom and VoIP systems. I'm passionate about the building a scalable infrastructure, and I love to do a coding, playing cricket, and the games. About INX, we empowering the small business to large enterprise through futuristic telecom software solutions. We providing a different services like a VoIP development, DevOps development, web development, and mobile development. We have our own products, ASTPP, a smart telephonic platform, iQualify, intelligent call center software, and Phonemo, a smartphone VoIP phone that will be work with the SIP.js and also supporting the WebRTC. About the agenda. So here are the agenda that we are discussing that are on the topics. So first one is why this topic is matter here to discuss. Who are the get the benefits after this topic will be solving. A real world scenario that will be set up the example like in the real world how this will be simultaneously set up. Architecture breakdown, implementation insight, what we achieved after gaining this all HA level setup of the proxies and key takeaways. Final conclusion of this whole over presentation. So start from the why this topic. So in this global industry, voice is a main global fundamental, but its reliability, compliance, and the quality issue is there in a local intelligence. So for that, customer want that compliance and regularity. Like every country have a different compliance. Like as in the US, there will be FCC. In India, there will be DRI. So every provider need like in the US, if I make a call, they won't ask me to give me the identity of steer shaken. But India carrier provider doesn't want that. So if you set up one server, every call reach there, and you generate steer shaken for every call, that will be making the loss. Because for the steer shaken, you need to add the certificate and all stuff. Similarly for try, in India, you can't share the recordings and voicemail to the another country. You need to store all the stuff in the Indian region. So similarly, this kind of challenges we got from the customer. One of the customer, we set up the VoIP system. They have asked for the multiple challenges, like my system is not auto-scaling. Like in a peak time, whenever the calls go high above the CC defined of the system, then it starts stopping the registration, calls, and all the stuff. That no auto-scaling, no load balancing, that kind of different challenges that we have noted down from the customer. There will be a registration and call spike, as you see. That will be stop working whenever the like 80% or CPU go high. Let's assume you have a set of 1000 CC call for the one of the server. And at this on the some of the peak time, that will be calls go like a 1000 and above. Then calls stop, incoming and outgoing, all kind of stuff. As we discuss about the compliance, so in the compliance, I mentioned that country specific, we need to define the different compliance. If in a region US, we need to define the steer shaken or another stuff. For the Indian region, we need define the another stuff. High latency issue is there because if I want to call to the India, but my server is set up in the US region, so Indian customer make a call, it will go to the US first. US customer route call back to the India. It will take a time, lot of time to traveling, and it will be make a high latency issue. So sometimes there will be making audio problems or delay in the call reaching. Their call connectivity is restricted because some of the country will be not open the 5060 port. Some of the vendor or Wi-Fi network provider also blocking that port for the security reason. So there will be some of the other challenges as there. So after solving this challenge, who got the benefits? Like as we see, these challenges are now in a routine. So in this, everyone who connected with this VoIP industry will be get the benefits, like enterprise customer, telecom providers, partners, reseller, developers, remote and hybrid teams, IT teams, call center. In the call center, there will be high call traffic volume. They also want to high scalable system and auto scaling. So these are the entities that will be got the benefits for all the stuff. Now, before starting go ahead with the technical, let me give you the real world scenario. So here the first diagram. In that, one of the vendors started his business in the US first. He's selling the many products, different kind of products. So he set up the US, one of the manufacturing hub in the US. Now he published his website, products.com. Many people go to the products.com from the global customer. Here I have set the 3 users from the global customer, USA, India, and Europe. 3 customers go in the products.com and submit like ordering some stuff. And orders will be reached to the USA warehouse. USA warehouse get the orders. They start packaging and dispatch the order. But there will be one difference here he getting. US customer get that product delivery within 1 day. Indian customer get delivery in 4 days. And Europe customer will get delivery in 2 days. As here clearly mentioned, show the delivery difference. It's also in a VoIP terminology you called as a latency. Because it's routing from the US to India back, it will take a time. So here the challenge happen in the vendor, they'll start losing the customer. Because customer in a hurry, they want a delivery immediate base, or they want product in a, like a tomorrow or in the previous day. They're finding the another option. So vendors start losing the stuff and they start losing the customer. So vendor thinking how I can take care of my customers. So for that, they have expand the business vertically. So they think my many traffic coming from these 3 regions. Why I can't do this to set up the manufacturing hub in all the region? So he set up one of the region in US, one in India, and one in Europe. Now what happened? Every customer will be satisfied. One level has been done. 1-to-1 has been done, like a US to the US. So every, like in the between products.com reach the request. Now every 3 customer will send request to product.com. But now product.com is doing a routing, geolocation based routing. Like if they understand this request coming from the US, they just send that order to the US region. If from India, they will send that request to the Indian warehouse. So that way, we have dilute all the traffic between the 3 regions. So by this way, all the customer now getting the delivery in one time. Now that by this setup, now customer will be increasing. So he start getting traffic more from the India now. Let's say, example, Indian people start ordering many things from the this side. But one manufacturing hub will be now stuck because let's assume they have a capacity of 500 order per day and they're getting requests of 1,000 order. So here order will be now start the delay. So particularly vendor think how I can take care again back. So they think about the auto scaling. Auto scaling is must required thing in the VoIP industry. Whenever required, it must be auto scale the node. Whenever decrease the unit time or load time, remove that node. That help to the cost effective because whenever you start node of EC2 in AWS, it will start billing you as use as you can pay. Similarly, here they start warehouse 2, only for India. In the US and Europe, they have a happy customer with that limited time. For India, they start the manufacturing hub 2. So now the customer will be get the deliveries again, same day or period of time. So that are the real world scenario. We use that similar fundamental to take care in the VoIP as well. So first of all, I will showcase the default architecture breakdown that customer will be giving us as a VoIP system. This one is architecture. So starting from the first level, there will be incoming call from the CPUs or carrier provider or any DID provider. We have one virtual IP. Currently, virtual IP work as a active passive. Like virtual IP, if on the OpenShift proxy 1, Then it proxy 2 work as a passive that will be not handling any incoming call traffic. Proxy 1 only handling all incoming traffic. So proxy 1 like a capacity of 1000 call. If any new coming call, it will not going to proxy 2 because it's an ideal condition. It work as a failover. So proxy 1 getting the call of multiple like 1000, 1001 and 1002. So here the first challenge, proxy 2 is not in use. That work as active passive, that will be not work now. Because we need to make a active passive not work, we need HA. Like if 1000 call has been capacity done by the proxy 1, add a new node, start new incoming calls to the OpenShift proxy 2. If the 1000 achieved, then add new node. So every time you need to add the node. It's called auto scaling group of AWS that will be do for you. Here the next part is a free switch. This is all flow is a hard code design of setup of cloud infrastructure. If OpenShift 1 dilute 1000 call to the 2 free switch like 500 call and 500 call. Now free switch have also capacity of 500 CC and 20 CPS. And also free switch 1.2 also same capacity. So if there will be a load increase, that start freezing, stop accepting new incoming call, stop registration. So that also start going down, and that shut down your system. And again, all running session will be not work. So that customer complaint, why my call is not working. That my disconnect in between the call. So here the whole breakdown that architecture customer given us. So we suggest to do one thing. We implement inside design some of the new way. They ask to set up in the AWS, use the AWS component and give me the highly availability and auto scaling setup. So in that part, we use these components that I have designed here. First is the Route 53. So AWS Route 53 is many kind of different approaches there. Latency-based routing, geolocation routing, and other also stuff. Customer want region-specific routing. So we use geolocation-based routing. So that will work for the routing to the different region as VPC created, virtual private cloud. The next is a NLB. NLB called as a network load balancer. It's a layer 4 protocol, TCP, UDP, and TLS that handled by the NLB. NLB is a low latency and high throughout the traffic handling system. So it was used for the traffic distribution between the different port. For the SIP signaling and media, we have used the EC2 machine, and there will be a OpenShift and free switch. And there will be using ASG multi-AZ. It means auto scaling group with multiple availability zone. So let's assume you set up the use the EC2 of India or US, it will always select from that region, specific region, to create the new node. So it will be like you have one virtual private cloud, one free switch has created, so it will be create another free switch on the same region instead of one on another region. So that has been done by the ASG multi-AZ. For the DB, we have used the RDS, Relational Data System. Here, the benefit of this RDS is, it will, first of all, here the DB, and there will be another standalone DB on the back. So one DB is down, automatically connection will be created in the new RDS system. And the last one is a S3 bucket for storing the voicemail and recording part. So first, starting from the single setup, we have start from the US part. So when customer want only US internal calls, that not required Route 53 because he know that I need to set every call in the US, so Route 53 is not required. Whatever incoming call arrived, we just need to send on the US East one, any EC2 instance. So first is the NLB. NLB as network load balancer. It auto scaling your OpenShift free switch both port, like OpenShift 1 have start running and it will reach to 80% CPU. It will set up the new OpenShift 2, again OpenShift 3. If the traffic go low, it will remove that node. So you have that benefit of the cost effective here, the AWS part. Also in the free switch, that will be similarly working, ASG multi-AZ. And the last one is the RDSDB, plus there will be a S3 bucket for the voicemail and the recording part. Now they want to expand the business similarly in the VoIP. So we added the new component, Route 53. And in the Route 53, whatever the request is coming, they will distribute between the particular region-based EC2 machines. In the components, you can use the alternative. You not need to depend on the AWS only. Instead of Route 53, there will be a Cloudflare. There will be a GeoDNS, CDN that will provide. You need to just incoming request is coming. You need to call third-party API from your virtual machine. You will get the location or particular user region. Then you need to pass to your virtual cloud because you use your own cloud on-premises stuff. It will like a HA proxy. Instead of NLB, use HA proxy, Nginx, and another stuff also provide to handling the load balancing stuff. For the ASG, auto scaling group, you can use the Kubernetes. You just need to containerize OpenShift plus FreeSwitch in one container. Kubernetes HLA will be do for you that a highly updated load application that will be do your stuff of auto scaling. So that also work for you. So there will be also multiple alternative option you can use here. And this is a full system with the region specific. First part that will be incoming call, entry point is only one. That is the world domain is sip.xyz.com. It is a DNS, domain name service. There, route will decide geolocation routing to which region I need to send the traffic. So there will be one of the Europe region VPC, one is a US region VPC, and on the right side there will be Asia region VPC. So during the starting of the business on the slide I have earlier mentioned, we start business from the US. So US RDS is work as a read-write. And we in the Europe and in the Asia, we clone, like a synchronization, we set up RDS is a only write operation, read operation. So what happened here, from the US, any insert query is coming, it will be right in the US, and this asynchronized will be quickly update on the both region. So Europe customer not need to send any data find during the Lua dial plan to the US region. They will look out in his local region RDS, and it will be getting the quickly output. So that will be save the many milliseconds of a time to make or reach the destination calls. So that way, in the also S3 bucket will be in a cross region. You can store every user's data and a synchronization between all the region. So here the full VoIP system diagram with the highly availability, auto scaling, load balancing. Here the main benefit is compliance mentioned. Like you want add only compliance of station in US region. So you need to do your logic between the OpenShift and FreeSwitch from the US region. If the try logic you want to apply of the Indian region of communication, you just need to apply on the Asian region part. So customer dilute and customer compliance also will be dilute from the every different region. Moving forward, what we achieved. So all things has been working, done. There will be many challenges I've showcased earlier. Now what we achieve after these challenges. So here, the mention point that we have finally achieved after this scalable solution, auto scaling of SIP and media layer, geolocation-based routing, multi-region availability there. Then also regularity and compliance. We have achieved that compliance-based certification there. Whenever the high traffic is there, you not need to down any server. It auto upgrade automatically. The new node has been added. And the peak load handling and cross-region replication also will be there. So these are the points we have achieved during the adding this part of all the HA system. The final key takeaways from this architecture of local intelligence. So here are some key points of the architecture that nowadays you need to make sure in the mind that failover must be required, because people want any time to make a call, and they want that every time my call will be work and it will be reachable and answerable. Second one is the quality. Call quality must be required. If the Indian user making a call or US customer making call, they must require the good quality and crystal audio. And the compliance. Every carrier or provider during the routing, they want some compliance certification. Because without compliance, they can't divert any call to the end user. It will be block your call. So that will be must required. So nowadays, compliance is not an optional thing. And the last one is a latency matter and geo-aware design. These are the final key takeaways for this HA proxies. That's our thank you.
Thank you very much, Pratik. We've got time for just one or two questions. If anybody has one for our friend here, pop your hand up and we will get a mic to you. It's looking like a no. Okay, in that case, let's bless Pratik with an extra ClueCon thank you.